So that's all from the session 2 for today. Now before further ado, let us start the session 3 for today. This session is chaired by Mr. Amanat Ali Bhatti, a name that is known to everyone, and it's an honor for me to introduce him as well. Dr. Amanat Ali Bhatti is a graduate of Petroleum and Gas Engineering from UET Lahore from session 1980s. He has joined UET as the faculty member in 1985, completing his master's degree and followed by the PhD during his service. He served the petroleum and gas industry and the department for around 35 years and got retired as a professor back in 2020. Additionally, he has also been involved in teaching under and postgraduate courses. During his professional career, Dr. Amanat Ali Bhatti had the honor to serve his alma mater on the Senate, the Academic Council, and other authorities as well. He has also been associated with Pakistan Engineering Council as a professional engineer and the first ever petroleum engineer as an elected member on the Board of Governors of Pakistan Engineering Council. Dr. Amanat Ali Bhatti, please honor the stage with your presence. Joining him will be Muhammad Arif as the co-chair for today's session. Mr. Muhammad Arif is the team lead production at Mari Petroleum Company Limited. He holds a bachelor's degree in petroleum and gas engineering from UET Lahore. His master's is from Norway. He has been associated with oil and gas industry for last 25 years, having a multi-dimensional industrial experience. Prior to joining Mari Petroleum Company Limited, Mr. Arif has also worked for OGDCL and ADNOC. Mr. Muhammad Arif, please come on stage. In the session 3 for today, in the last session for today, 3 papers will be presented. The first paper which is going to be presented will be Comprehensive Liner Inspection using Smart Integrated Acoustic and Caliper Logs.
I'm so privileged that I've been introduced by one of my students, Sahar, and also honored. The co-chair with me is also my student. So what I see in the list of the presenters, the mostly are my students. So honored. Thank you, sir. Please continue.
It's an honor for me, sir, to introduce you as well. So the first paper for today's third session would be presented by Mohammad Sohaib Tanveer. He is currently working as a production engineer in Schlumberger, Pakistan, with a diversified experience of almost 5 years of production logging, formation testing, well integrity barrier evaluation, and the well test interpretation. Mohammad Sohaib Tanveer, please join us on stage.
Thank you, Sahir, for the introduction. Sorry?
Okay. Are you in, Sohaib?
Sir, I'm here. Just checking on the presenter. So, Bismillahirrahmanirrahim. First of all, I'd like to thank you all for being here and joining me on the presentation of my paper, which is entitled as Comprehensive Liner Inspection using Smart Integration of Acoustic and Caliper Logs. My name is Mohammad Sohaib Tanveer and I'm working as a production engineer with SLB for the past 4 to 5 years and have a diverse experience in borehole reservoir and production engineering business. So along with me, I have co-authors collectively from MPCL and SLB. I'd like to thank all of them for their valuable contributions for the success of this paper, namely Mr. Abdul Bari, Talha Zubair, Muhammad Rashid Khan, and Aliza Tahur Asif from SLB, and Mr. Sahir Inam, Muhammad Sanaul Hasnan, and Rafiullah from MPCL. So thank you all for your valuable contributions. Moving on to the agenda of today's presentation, I'll very briefly start off with the importance of well integrity itself and the gist of well integrity, as it includes not only cement evaluation but also the tubular integrity itself. Then we'll be seeing what are the common techniques that are common in the industry right now for corrosion evaluation. And since my paper is mainly related to the principle of ultrasonics, so I'll very briefly just go through the physics of the tool itself, how the ultrasonic tool works. And finally, we'll be deep diving into the case study and see how this integrated evaluation has helped to comprehensively allow the liner evaluation. My Q&A session will be entertained at the end of the presentation. So, as we all are very well known with the infamous incident of Macondo and other incidents as well, which have been happening in the past for the well integrity. On the right side of the screen, you can see some pictures which are devastating in their nature, but were happening because of the tubular integrity issues in some field in Kuwait. So, therefore, this well integrity has been the epicenter of the QHSE for the past 10 to 15 years mainly, with revised in standards and updated standards being introduced day by day, like NORSOC, ISO, etc. And hence, there are now dedicated well integrity management systems being introduced, with dedicated teams being devised in the organizations who have the core responsibility of looking after safe execution of the well and field's operational phase. Therefore, in order to update the status of well integrity, be it cement or corrosion, there is an increased need for the barrier verification and hence an increased need for the wireline evaluation services as well. And this, the importance of this particular slide is just to highlight that it's not only cement that has to be made integral as part of the well's safety procedures, but it also depends on the casing conditions as well. So some of the common techniques that are implemented right now in the industry start off with the very common ultrasonic tools, which basically provide an azimuthal coverage of the casing condition. And we can know the information about the internal radii, the thicknesses, as well as the cement integrity from these ultrasonic tools. Then we have some visual inspection tools such as downhole cameras, which basically tell us about the status and image of the actual tubing that we are logging in. Then on the right side of cameras are displayed the mechanical calipers. Now these can be multi-arm calipers or these can be multi-finger calipers as well, which also give a radial resolution azimuthal coverage of the tubing that we are logging in. And finally, there are some electromagnetic tools which can provide either a collective thickness of the concentric pipes, or they can also provide individual thicknesses based on vendor to vendor. All right, so the ultrasonic tool itself, as I've displayed on the right side of the screen, has a rotating transducer at the bottom, which basically provides the azimuthal coverage for the inspection of the casing itself. So a sonic beam basically is basically highlighted, which basically moves towards the casing wall, and based on the reflection and refraction of this particular sinusoidal wave, there is an algorithm which is processed to give us the output in terms of casing thickness, internal radius measurement, as well as the cement impedance. So with the ultrasonic tool, you can have up to 72 azimuthal measurements spaced apart by 5 degrees each horizontally, right? So it's a very, very robust tool with very high accuracy, very high radial resolution, which helps us to basically evaluate this casing condition. Now, if I start off in my case study, this well, subject well, is basically a deep exploratory well, which was drilled in Pakistan with its TD exceeding 6,000 meters. So during the drilling of the 6-inch open hole section, compression of up to 6,000 pound force was observed on the drilling BHA when stripping in and out of the 7-inch liner section. However, despite this challenge, the operator decided to complete the 6-inch to the target DD and successfully acquired the formation evaluation logs. Now, while giving prime importance to the well integrity itself, the operator decided to assess the 7-inch lining condition first and decide the way forward prior to the testing operations. So in such a high profile well with high stakes, a comprehensive and integrated approach was taken to evaluate the condition of the liner. And hence, it was decided to not rely on a mono-source evaluation, rather go for a multi-source evaluation with both ultrasonic tool and mechanical caliper combined together to assess the liner condition itself. So the methodology started off with the real-time monitoring. Since it's a wireline measurement, real-time data was being monitored at the surface job optimization was done with some high resolution passes taken, ensuring data consistency and QC of whatever we are getting at the surface. This was followed by the processing and orientation of the of the data that was collected in a industry standard software. Finally, a detailed corrosion summary report was generated from this one. Now, integrating this ultrasonic data with the data from the mechanical caliper, all of these individual data sets were then put together and they were taken out from their individual silos so that an integrated and comprehensive evaluation can be done of the liner condition and assess what is actually happening in the downhole. So before moving on to the results, I'll very briefly explain the log header first. So starting off with the first track is the LQC track, where you will have the tool centricity being measured in real time, followed by gamma ray, which is the depth correlation. Then we have a number of tracks for internal radius, echo amplitude, and thickness and internal radius maps, which are being generated from these 72 measurements at single depth and single point of time. Then the last 4 curves, these are coming from the mechanical caliper. So it's a 6-arm caliper which gives 6 radius measurements, and these 6 radius measurements are then combined together to give 3 diameter measurements itself. All right. So first of all, I'll display a cleaner liner section just for a reference. So what you can see on the screen right now is a cleaner liner section with manufacturing patterns very clear on the radius and the thickness map, the light blue and the light reddish color. And if you see the last 3 tracks, the radius from the mechanical caliper is also correlating very well, and there is no anomaly or any distinct change or spikiness in the caliper reading as well. So both of these readings are correlating very well across the clean liner section, and both are basically close to each other in terms of the numerical values as well. However, if we move towards a different section of the liner, we can see that there are dark stripes, blackish stripes on the echo amplitude map, followed by blue and red alternative colors, dark colors on the radius and thicknesses map as well. So these indicate severe damage on the liner. This is coming from the ultrasonic data. And when this is combined with the data from the mechanical caliper, we can very clearly see that there's a tortuous liner path which the caliper is following on this particular, in this particular interval itself, right? So the damage is there both on the ultrasonic caliper, ultrasonic measurement, as well as the mechanical caliper. And when these both are integrated together for a single log display, you can see that there is a liner buckling happening across this particular interval, which is causing the drilling BHA to basically have some compression of 6,000 pound force across this particular interval. Now, had this been an independent measurement of ultrasonic alone or an independent measurement of the mechanical caliper alone, we could have only estimated the damage itself. But once they are combined together, both of these integrated data sets from individual silos help to understand that this is not only a damage on the liner, but it's also the buckling of the liner itself. So what you see on the left side of the screen is a corrosion summary report, which is a smart and quick look analysis display of the casing condition. With this corrosion summary report, you can easily and quickly assess your liner condition very smartly, because you have graphical values on the left side of the depth track, a graphical log, and on the right side of the depth track, you have the numerical values. So joint by joint, you can know your damage, your maximum metal loss, as well as the exact depth of that minimum thickness or your maximum internal radius. So with the help of this integrated analysis and integrated log, the client was able to restore its well barrier integrity, and as a result they extended the top of their 5-inch liner up to this particular depth so that they can have safe and safe operations in the future for the testing as well as for the completion in their target TD section of 6-inch. So with this holistic corrosion evaluation using multi-source data, basically the well barrier was successfully restored, and the operator had assessed the risk potential based on the combined analysis of these data sets. So on behalf of all of the authors, I'd like to extend sincere gratitude to MPCL as well as SLB for allowing us to publish and present this work. And I'd also like to thank and acknowledge the SP Pakistan section who have done a very good job in arranging this successful event. So thank you. This is all from my side. And now the floor is open for question and answer session.
Thank you, Shoaib. आप तो माशाल्लाह before time you wound up, right? Okay. I don't know exactly what to say about the things, the contents, but I open the house for the questions. So please raise your hand before you ask a question, and please do introduce yourself, your affiliation. Any question, please? Yeah, please. Shah? Please pass on the mic.
Shah Jahan from Mall, Pakistan. It was a very well presented presentation. So my question is about the buckling part. So at the end of this entire study, was there any root cause identification that what could have triggered the buckling, and how it can be prevented in the future? This may not be entirely related with the content you have presented, but of course we will be interested in knowing if you have any insight to that. Thank you.
So thank you, Mr. Shah Jahan, for the question. Yes, there for sure there is some event during the drilling phase that was basically the reason for this buckling, but I believe I'm not at liberty to explain it because it is mainly not public from the MPCL part.
So, anybody else? If there's no further question, we can move on to next presenter.
Thank you.
Thank you, sir.
Thank you, sir.
All right. The second presenter of this session is Rafia Sayyed from UEPL, going to talk about successful analytical modeling of a complex dry gas field to identify potential infill opportunities. Rafia, please. Sahar? All right, thank you.
Assalamu alaikum everyone. This is Rafia Sayyed from United Energy Pakistan. I am here to present my paper based on the successful analytical modeling of a complex dry gas field to identify the potential infill opportunities. And I look forward to share the findings as how the simple MPAL tool can provide a base for identifying the future opportunities in a very complex and the challenging field. So for the agenda, I'll briefly go through the field introduction and the background slides. In the analytical modeling part, I'll cover the multi-tank model, the workflow used, and the history match sensitivities performed. Then we have the results, and in the end, conclusions with some future recommendations. Okay, so the field under discussion is an onshore dry gas field which was discovered in 1993 and is producing mainly under the depletion and the water drive mechanism. We have two major sands here, conventional at the top and tight sand at the bottom. Here, reservoir is quite heterogeneous and compartmentalized by faults, with the porosity up to 20% and permeability ranging into multi-darcies. We have total 36 wells drilled here, and from which 700 BCF has been produced up till now. Under the field background, there are several compartments of the field, but only the compartments which are under concern I have mentioned here. First, we have the X1 compartment. It came at an initial pressure. We have total 6 wells drilled here with a cumulative production of 150 BCF against the JIP of 208 BCF. Currently, no wells are producing from this compartment and the compartment is watered out. Next is the X26 compartment. It came at a slightly depleted pressure, which suggests its communication with some other compartments, which we will look through our modeling. Here is only a single well with a cumulative production of 0.1 BCF against the JIP of 14 BCF. Next, we have X5 compartment. It also came at an initial pressure. We have total 5 wells drilled in this compartment with a cumulative production of 242 BCF against the JIP of 140 BCF. There are 2 wells producing from this compartment at a very stable rate, which shows its communication either with the tight sands below or from the adjacent compartments, which we will find out through the modeling process. The last is the X11 compartment. We have total 5 wells drilled in this compartment with a cumulative production of 156 BCF against the JIP of 190 BCF. Currently, no wells are producing from this compartment as well. So, using these 4 compartments, the analytical work was performed, for which 3 objectives were set. First, we need to establish the JIP connected to each compartment and the behavior of aquifer in them. Second, we need to evaluate the higher cumulative production of the X5 compartment and the stable performance of the existing producers X17 and X25 well in the similar compartment. Next, we need to find out the reason for the surprising result of the X26 well, which came at a depleted pressure, although it was assumed to be at virgin and fully gas bearing. So, keeping these objectives in mind, the workflow was defined. This slide provides a visual overview of the workflow used. 4 tanks were created, considering X1, X5, X11 and X26 as separate compartments. The model was then initialized with the static in-place estimates and the tank parameters. The communication between the compartments was captured through the transmissibility, which basically represents the fault behavior responsible for the compartmentalization of the field. Then the valves were connected to their respective compartments and all the available pressure and the production data was added in them. Finally, the individual valves gas rate and WGR match was performed by changing the pseudo-relative permeabilities, tank transmissibilities, breakthrough saturations, and the aquifer strength. So for the history match, we have 2 cases. For the case 1, the model was set up based on the conventional sand compartments and they were connected to each other through transmissibilities. For the case 1, no recharging was considered from the tight sands. However, for the case 2, recharging was considered. In case 1, where we have no recharging tank, the performance of the field was tried to match with different parameters. The X11 compartment at the extreme right in the picture and the bottom X1 compartment was tried to match by controlling the transmissibilities and the aquifer strength in them. However, the main focus was to match the X5 compartment and the X26 compartment. So, for the X5 compartment, the major gas influx was considered from X26 well and the X11 compartment, and the major water influx was considered from the X11 compartment. However, none of the options lead to a better match for this compartment. For X26, its pressure and sweep was calibrated through the water movement from X1 to X26 compartment and its gas migration from its own region towards the X5 region. These are the pressure matches for the case 1. For X1 compartment, the decline in pressure was achieved, however, its increase in pressure could not be matched. For the X5 compartment, The stabilized pressure trend could not be matched with the combined influx from the X1 and X26 compartments. However, for the other two compartments, the match was reasonable in this case. So this suggests that there is an additional hydrocarbon source which is providing the pressure support and gas recharging. Therefore, another case was run considering the similar parameters as in the case 1, except an additional tank was connected to the X5 compartment, and the communication between these two compartments was made after a certain threshold pressure. One issue that we were getting in the case 1 was the X1 compartment's pressure match. So since we are not considering a very major influx from X26 and X1 compartment towards the X5 compartment, therefore it was easy to match the X1 compartment's pressure trend by the use of transmissibility and the aquifer parameters. These are the pressure matches for the case 2. For X1 compartment, its decline and increase in pressure was achieved. For X5 compartment, the pressure trend was justified by the tight gas recharging, and for the two compartments as well, there was a reasonable match. So, since suitable pressure matches were obtained for this case, therefore the WGR match was performed for the individual wells by controlling the gas rates and regressing the pseudo-relative permeabilities for the individual wells in each compartment. So the suitable match was obtained for all the wells in the X1 compartment. Similarly, the suitable match was obtained for all the wells in the X5 compartment. And by regressing the same relative permeabilities, suitable match was obtained for all the wells in X11 compartment and for X26 well in the X26 compartment. So from this analytical modeling work, there are 4 outcomes. First, we were able to achieve a reliable match of pressure and WGR for each compartment and their respective wells. We were able to estimate the jib connected to each compartment and the aquifer behavior in them. We were able to prove the hydrocarbon recharging in the X5 compartment was mainly due to an additional tight sand source with a jib of around 142 BCF and very marginal contribution from any other compartment. And the 4th outcome was the X26 pressure and sweep, which was matched through the water movement from X1 to X26 region and its gas movement towards the X5 region. These two tables show the tank jibs and the recovery factor for the 2 cases. To conclude, the work basically focuses on the successful analytical modeling of a highly compartmentalized and a large dry gas field, where the complexity of the compartments which are under different drive mechanisms provide the challenges can still be resolved using the simple material balance tool. It demonstrates the opportunity to enhance the production and the recovery from the field. So for the future, the results of this work can be used in the detailed numerical simulation modeling to further mature the opportunities, especially in the compartment where the tight gas recharging is proved. In the end, I would like to thank all the colleagues and the partners for their support in this study. Now I invite any questions or comments you people have.
Okay, thank you. So, don't know what to say, that 15-minute presentations are ending up in 10 minutes. So there is one question, I think. Yes, Safraz.
This is Sayyid. You have presented, can you go back to your conclusion slide? Yeah, the conclusion slide. This is outcome. The third point, the study helps in identifying the region of remaining potential which can be exploited. So Can you explain that how you have evaluated that? Because you in the material balance equation you have, in the ML modeling or whatever the tool you have used, you have put a gas in place, initial gas in place.
So the remaining potential here is basically focusing on that compartment which is basically charging from the tight gas. So here this point basically refers to that particular compartment.
No, you have identified that this is the remaining potential like that if you have drilled 5 or 6 wells.
Okay, so I can show you like here. If you can see for the case 2, the X5 compartment, the production is 242 and its initial JIP was around 140. But with the tight gas recharging, which the match was obtained with the 142 PCF. So the overall recovery factor is still there to produce from this compartment.
Okay, thank you.
Yeah. Any more? किसी और साहब की तरफ से या खातून की तरफ से कोई सवाल है? Okay, thank you, Rafia.
The next paper is From Planning to Execution, a success story of integration to tap concealed reservoir reserves in Tull block. And the presenter is Mr. Mohammad Usman Shah from MOL.
So, Assalamu alaikum, Bismillahirrahmanirrahim. So before I start the presentation, I just want to share my observation. Before I was looking at the NFR behavior in the Pakistan fields and looking at the PPIS data, and it was about more than 52% liquid hydrocarbons and more than 50% LPG that is coming from the NFR reservoirs. So these NFR reservoirs, when I look into deep, with the less intensity of wells, you are getting the more productivity. But there are some wells, if you look at these NFRs, you have one well here, and after 500 meter, there is another well that is producing 100 of barrels, and the next well that is about 1 kilometer, 1000 meter, it is producing about 1000 of barrels. So what is the difference? What are the challenges that if from the one well in the same compartment, in the same environment, we are getting less productivity, and in the another well just about 500 meter away, you are getting 1000 of barrels. So, and we will discuss about the same challenge actually we faced in this study. It is a success story of a field in a Tull block. Yes, so it is a field in the Tull block, an NFR field. And in the Tull block, most of you are aware about that. The main reservoir is the Lukhat reservoir. And then we have the Lamshiwal and some other reservoirs, Hangus, Manasuk, Shinabri. So if we jump back to back in 2021, we have only one well in that field. This is well number A, we can say that. This field is discovered in 2016. We have only one well. It was only producing about 6 million SCF per day at that time, and with a high rapid decline rate. So if you look at that well potential, the opportunity to develop that field was very limited. And you have a second well case in a 3P reserve. So it means that you have a very less chance of success with from the second well. So there are some challenges in that field, and especially because of that complex geology in Tull block, you have some challenges just like a field delineation, lateral variation of reservoir characteristics, and then we have also some low quality seismic data. So about before I go into each of the detail, just want to give you an overview about what was actually from the start to the end, what we did, and how we can execute it successfully. So starting from the planning. In the planning, there is always a continuous monitoring of the data, but it should be integrated with the efficient data gathering. The challenges you are facing and the data gathering according to that. Was the biggest one in the planning phase. And then there is evaluation, project maturation, and the classical reservoir engineering tool. It is the even we have the simulation tool and everything, but this is the strongest tool in our reservoir engineering in petroleum industry. That classical reservoir engineering evaluation tells you the story that what the well is looking actually. And then the coordination between your other departments, intra-department, just like the exploration and the other colleagues and the production. So it is the integration. You observe something in a classical reservoir engineering, you should pass it to your exploration, your G&G guys, your production guys, to best optimize, to best mature your project. And then there is about a key success is about a successful drilling plan and a completion plan. And other than that technical sides, we also have to look about the management side, that the effective approvals, timely approvals with the strong justifications, with a strong technical background is very important to get the approvals on time. And the most important part is the execution. Safety first, and then your drilling should be efficient, your formation evaluation should be efficient, testing strategy, optimize completions, and everything. So then you can add a successful project from planning to execution. So this slide, this is an important slide in our case. This is a core of our project actually. So when we look at the pressure data in just like for the first years, if my laser work, okay, on the first graph on the left side, if you look at here, we have some pressure points in the yellow colors. And if we look at that, this is about 72 hours pressure buildup. And by using that point, the well actually, if you use that point and do your classical reservoir engineering, your reserves are very limited. Even the one well can drain that. But there are some things actually, when you do that pressure test interpretations and everything, we have the feeling that this pressure is not truly representative of the whole reservoir. Maybe it is a representative of that well, but there is something it is looking after that. And that's why, so this, you can say, a very slowly build up pressure points, they are actually the misleading data. That is misleading our reserves, our well potential and everything. And then, so it led us to do this to increase the build-up time from 72 hours to 129 hours. And in Pakistan, it's very difficult to shut in the well for the long time. But if you have a strong justification, you can do that. And by increasing the time to the 129 hours, you can see the point here, this the third one in 2018 and 19, you have a higher pressure point in other than that 72 hours. So it means there is some issue that your pressure is actually building up, you have the more reserves. There is some permeability and isotropies, that you have more reserves on the other side of that the well is not draining, well is looking at its own reserves, and it is taking too much time to see that reserve. So it led to the improvised data in 2019 pressure buildup. And so when we do that pressure buildup, you can see that and use that buildup in the analytical evaluation, just like in the material balance. By using that extrapolated pressures, high pressures, our reserves get then more than double. We jumped to the 70 BCFGA. It is in the Lamshiwal formation that was producing at that time. So this pressure data point, actually it unlocks the opportunity of the second well, which is showing that you have the reserves and you can drain that. But there is now, the next question is that, okay, the how to drain that? You unlock the opportunity, but where to put that well for the additional recovery? So, as you know that we have had only one well. So on the one well, and then we have, you can see that low resolution seismic data, and then there is too much heterogeneities. So to cater all of these heterogeneities, we have to build an integrated model that incorporate all the data, that actually incorporate the seismic, that incorporates your geology, your pressures, your well behavior and everything. And also this material balance, actually, when we look and when we observe that there is some additional reserves associated to that, we pass that information to our G&G colleagues and ask them to please re-evaluate the seismic map, seismic interpretation. We are anticipating that there is some opportunity that may be masked due to the low resolution data. And that actually, when they did the reinterpretation of that seismic data, we have a different map than the original one. Then we have some updip location. We can look into the seismic, seismic map. And by using that map, we built the geostatistical model and dynamic model. And by using that one well data, we actually make the too many uncertainties analysis on the different parameters, but by making some, you can say, intra-region communications between the downthrown side and the upthrown side, and the permeability anisotropies and the fracture intensities. So every uncertainties, we just write it down and make the runs so that we have a probabilities of the uncertainties and we have the range that whether it can be successful or not. And there is one picture in which you can see that it is matched. Okay. So this is one of the picture, some of the compartment. Our well B, that was a existing well. It is on that downthrown side on the new seismic interpretation, and then we proposed a well on the well A. So the challenge is actually here to where to put that well, because in a well B, that is actually producer, we encounter a very lower productivity. And and the one surprise actually we faced in a well B, that our main producer in a Tal block, that is Lukhat, actually didn't contribute. It was proved tight in the first well. So what we did actually, the challenge actually to see that why it was not producing and do everything in capture to that in reservoir simulation. Okay, and as you know that we are making model based only on one well. So we have a large uncertainty, and if you go with a one well model, simulation model, it has a lot of uncertainties, and you need to prove that. How you can prove that? So we have the option actually to do another build-up, extended build-up, and then to see that whether it is fitting our simulation model or not. And actually what happened when we do that build-up in 21, with the extended one, you can see that it's about a 6 days or 5 days build-up, and then we put that pressure in our prediction case. Actually it was matching with that. So actually it proves that the simulation model actually it is giving us the right direction. And it also helped us to get the project approvals and everything, that we have the confidence in our model. So another thing, just like I reiterate many times, that we were concerned about the Lukhat reservoir. It was a major producer. Why it was not producing? So here it is an innovation actually. So we look at the you can say the dips. We look at the fracture sets, And we observed that based on the offset wells data in the existing well and in the offset fields, we see that the dominant fracture pattern actually it is striking from northwest to southeast. So to cut that maximum fracture, to get that maximum productivity, we have to do plan a wellbore trajectory that intersect maximum fracture out of that. And here we did, you can observe in that cartoons that how the blue one fracture sets, this is attributed to the Lockhart, and the green one, it is attributed to the Lamshi-Wall formation. So they have the different striking pattern, and you have to optimize your trajectory to cut the maximum fractures so that you can, the aim is to not get the surprise just like we have in well A. So what we did actually, we do the 25-degree angle at the top of Lockhart formation with a 230 to 260-degree azimuth to get the maximum fracture actually from the perpendicular direction to get the maximum productivity from this well. And we also did some other sensitivity TVs to do the
last minute for presentation.
Okay, sir. To do that uncertainty, we do the you can say the frac option, horizontal option, and everything. And this deviated well option proved to be the a good option for that. So for the project execution, when we drilled that well, the Lockhart encounter actually it is shallower than what we prognosed. So it was a very pleasant surprise. And then we had the opportunity to drill these deeper horizons also, that is Manusuk and Shinawri. And some of the key milestones I would like to highlight here, that in that case, it is not only the reservoir planning and anything, it is also the drilling planning optimization, which also results in cost and time savings of 34 and 40%. And the main, actually, the critical path of this success, of this successful execution was the project management on the management side during all the phases which led to that. And in the tested results, these all three formations. In a well A, we only tested one formation, but in a well B, when we do that uncertainties on everything, the results was very good. Three formations, all the three formations tested successfully, and the Lamshi-Wall, it is tested with a better productivity. And the Lockhart, it was a discovery here in that field, and then the other two formations were also discovered. And there are some challenges faced and mitigation. Just a holistic view about that. We have a very low resolution seismic data, and for that actually and low permeability reservoirs. So just going to the conclusions. So on the conclusion side, the main thing that by these efforts, by integrated team efforts, we got the 50% incremental production rate. That what we actually was expecting from other wells in the same area. And the designing of the wellbore trajectory, that is a very critical part in enhancing the productivity of Lockhart reservoir that was not producing in a well A, but in a well B, it produced about more than a 10 million gas. So we have the enhanced productivity by using that wellbore trajectory also in a Lamshi-Wall formation. And at the end of that, this is not a single person success, it is a multidisciplinary approach. And it was the success actually of all the team, and which results that which narrow down the uncertainties in a complex heterogeneous naturally fractured reservoirs. So that's all from my side, and I am thankful to MOL Pakistan and management to let me present that content.
Thank you, Usman.
Yeah.
Now the floor is open for the question answers. Is there any question from the audience? Yes, Afraz.
Thank you for presenting this wonderful presentation. You should be also thankful to SP Pakistan for giving you the opportunity.
Sure, sir.
The question is that why you have been discussing during the start of your presentation about the pressure buildup analysis. So I'm not clear on that you said that you use a small duration buildup and then you analyze, and then that's basically is giving you the wrong indication, because when you put that pressure point to the material balance, that's basically your curve will shift down. But again, my question is that because of the reservoir heterogeneity and the permeability barriers and other things which basically reduces your pressure communication within the reservoirs, but this also basically gives you an impact on your overall reservoir pressure drops.
Yeah.
Because in the low deliverability reservoirs, because this is a low deliverability reservoir,
Yeah.
if I correctly understand, in the low deliverability reservoirs, the pressure also, basically depletion is also slow. So you have to explain this, put it in your presentation or next time or any other thing.
Yeah.
Because you have explained very well that you are not correlating your pressure buildup on alone pressure buildup, but you also use the geological information to correlate that. That's the exact way of doing that.
Yeah.
So that's only a comment. Thank you very much.
Yeah, welcome, sir.
Is there any question, any other question from the audience? Thank you, Usman. Thank you very much.
Yeah, thank you, sir. Thank you, everyone.
With this presentation, it's the end of the session 3 for day 1 and the day 1 sessions as well. So it's time to hand over the shields to the presenters and the co-authors for the papers that have been presented in the 3rd session. So the first paper that has been presented in session 3 for today was Comprehensive Liner Inspection Using Smart Integration of Acoustic and Caliper Logs. Paper was presented by Mohammad Sohaib Tanveer. I would like to call Mohammad Sohaib Tanveer to be on stage. I will request the chair and the co-chair to please hand over the shields to Mohammad Sohaib Tanveer. Mohammad Sanaul Husnain. नहीं हाँ ठीक है रफ़ीउल्लाह साहिर इनाम Raffiullah and Muhammad Rashid Khan. I will request Mohammad Sohaib Tanveer to collect the shield for Muhammad Rashid Khan as well. The second paper presented in this session was Successful Analytical Modeling of a Complex Dry Gas Field to Identify Potential Infill Opportunities. Papers were presented by Rafia Saeed, Saad Mahmood, Abdul Azim, Muhtashim Ijaz, and Muhammad Atar Sarati. The last paper presented here today was From Planning to Execution, a success story of integration to tap concealed reservoirs in Tal block. Paper was presented by Muhammad Usman Shah. Jawad Ahmed, Umar Farooq, Saqib Ali, Jawad Nazir. Now I would like to request Syed Afraz Haider to please come on stage and present the shields to chairman and the co-chair for today's session. The third session was chaired by Dr. Amanat Ali Bhatti. And co-chaired by Muhammad Arif. So with this, all the three sessions for today has been ended. Thank you, ladies and gentlemen, for being here for such an interactive audience. Hope to meet you tomorrow for the next sessions. Hoping to see you all at the gala dinner as well.